Hello everyone. I'm going to show you how to use the activity series today. So you should have your solubility rules in front of you, and we're actually looking at the bottom of that sheet. It says Table 7-2 Activity Series of Metals. So I've made some notes of what you need to know about the activity series. First of all, you need to know that this is only going to be applicable for single replacement reactions. Why do we use it? It helps you determine if a single replacement reaction can take place. And the way the metals are listed is according to decreasing activity, with the most active metal listed at the top. So according to this list, the most active metal would be lithium, and the least active metal would be gold. And the way this works is that metals can replace other metals that appear below them on the chart, but they cannot replace metals above them on the chart. So to give you an example, I have two equations here, two single replacement reactions. In the first equation, we're trying to determine whether or not magnesium is reactive enough to replace lithium in this equation. Well, if you look at your chart, lithium is at the very top, meaning it is the most active metal, and magnesium is below it. So since magnesium is below it, it is not active enough to replace lithium in that compound. So we would write out to the side, no reaction. This could not happen. For the second equation, now you see that lithium is the metal that's by itself. So we're trying to determine, is lithium reactive enough to replace magnesium in this compound? And once again, the fact that lithium is above magnesium in the chart means that yes, it is active enough to replace it. So we would go ahead and predict the products like normal. Lithium is with chlorine, magnesium is by itself, and then we would need to balance the equation. Don't forget, the reason why I dropped off this 2 on chlorine is because lithium is +1, chlorine is -1. They cancel out. All right, another demonstration that I normally do for my students is called the hollow penny demonstration. So something you might not know, a lot of people think that pennies are made of copper. They used to be made almost entirely of copper. So pre-1982 pennies were 95% copper and only 5% zinc. And the reason they changed that is they realized that copper is more valuable than just a penny. So post-1982 pennies are made mostly of zinc with very little copper. So a demonstration that you can do to prove this is to put an old copper penny, again this is pre-1982, if you put that in hydrochloric acid, we're going to predict what should happen. Versus if you put a newer penny, anything after 1982, if you put that in acid, what is going to happen? Well, if you look at our activity series chart, here's copper, and right above it is hydrogen. Because remember, if this reaction were to occur, copper would be replacing hydrogen, and hydrogen would be released as a gas. So the fact that copper is below hydrogen on this chart means that that can't happen. If you put a copper penny in hydrochloric acid, one that is pre-1982, you can leave it in that acid for a few days, and at best it will just make the penny very clean, but it won't eat away at the copper. So we are going to say no reaction for this. If you take a newer penny, anything after 1982, and you put it in acid, you'll see that zinc is above hydrogen on the chart. So zinc is reactive enough to replace the hydrogen. So that means zinc is now with chlorine. Remember, zinc has a +2 charge, so that's why I crossed the 2. And hydrogen, remember, hydrogen is a diatomic molecule. If it is not paired up with a different element, it's going to exist in pairs, and this would be hydrogen gas. And then, of course, we would need to balance the equation. So since I can't actually demonstrate this for you, I found a picture of what this would look like online. So remember that the penny still has an outer coating of copper, but the interior of it is zinc. So after you leave that penny in acid for a few days, all of that zinc will be eaten away by the acid, and you're just left with a hollow penny, just that copper shell. And it feels really weird. It feels like paper. So anyway, this is a question that you will see on your reactions test, and I just wanted you to be aware of how I want you to explain that question. You'll talk about the reactivity series. You'll explain why copper can't react with hydrochloric acid, but zinc can. And you'll need to prove that using an equation. So please let me know if you have any questions. Remember that this lesson only applies to single replacement reactions.